Welcome back, guys. This is the third video of the video series for RHCE, and I'm Arash. So let's begin. Basically, the topics that we are gonna cover in this particular video will be these. Just hold on a second. Yep. Sorry. So these are the topics that is gonna be in the next video. The first topic will be the Vim editor. The second topic will be the installation and the partition of for Linux with the RAM architecture, the swap partition, what it is, why it is used, types of swap partition, how basically the swap partition is used, configuring your system as an NTP, that's network time protocol server, some basic commands that will come handy to you in the whole throughout this video series. Then we'll see managing the physical partition storage part 1. We'll go through what are symbolic links. We'll review file permission and securing Linux files access for the read, write and execute permission, the spatial bit permission and the access control list permission. Then we'll be doing log analysis and storing managed system services and looks. So let's begin. Okay, so the first thing that we have to cover in this particular video is the Vim. Now I'll wish to start with a challenge in this particular video. In the previous video I have made a minor mistake. It was a minor mistake. Now your challenge will be to find out what that particular minor mistake was. So let's start. Let me open some file for you. Okay, sorry. Yeah, so what we are gonna cover in this particular module, the Vim module, is the modes of the Vim editor and a few basic commands for accessing or for working in the Vim. Now, as I've told you, there are basically two modes of Vim. That is, first the command mode, which opens by default. We are right now in the command mode, and if we press I, it comes into the insert mode. Now there is a third mode, and that's the visual mode. Now I do not have a pretty much specific knowledge over what visual mode, so can't actually tell you more on this, but the basic usage will be of either of the command mode or of the insert mode. So the what basically is the difference between these two modes are the whole editing is done in the insert mode, and the shortcuts, if you have to perform some specific kind of task, that you do in this command mode. Now the few shortcuts could be as for in case if we have to delete some particular specific line, we'll use D 2 times. That's we'll be using double D, caps lock, that's in a smaller case, double D, and that particular line will be deleted. Now the other shortcuts can be double Y, and that's for copying. Okay, just a sec. Now for in case you have copied, now what if you have to paste it? P is the command for pasting it. As you can see, it has already taken a step downward. I have already created a space between the previous line and the new line that's being pasted, so that goes unsaid. Now for in case you have to undo the steps on or you have to undo the things that you have already done, what you can use is U, a simple U, and all the editing that you have done in the last step will be reverted back to the step previous to it. Okay, so apart from this, there are other shortcuts, as like you can use a small G 2 times to go on the top of the file, a capital G to go to the end of file, the dollar sign, that's shift plus 4 can be used to go to the end of the line. Okay, apart from that, as I've already told you, W and Q is for write and quit. only W is for write, Q is for quit. WQ exclamation mark, that's for save and quit forcefully. This, and the altered version of this command can be only quit forcefully. Okay, and sorry, apart from this, there is one more command for save and quit, that's capital Z 2 times. It will automatically save and quit for you. Now if you have to search through a particular text or a particular pattern throughout a file, what you can do is a forward slash and that particular pattern that you have to search. As for instance, in this case, let's search 69. That's the only single instance of this particular pattern 69, and the Vim has already found it and took your cursor over to the founded pattern. Now if you have to move on some particular specific line, you can just put a colon and the line number. Let's go to the line number, like say 5. We are on the line number 5. Apart from that, there are some more commands, as for in case if you have to copy a particular specific number of lines, what you can do is you can input the number of line and then press Y. That is that Y stands for yanking. So by that you can copy a particular number of lines on your demand. Let's like copy 11 lines this time. Sorry, I beg your pardon, you will have to press the Y 2 times. Okay, so after that you can paste it anywhere you want. As you can see, I have already pasted it. From 54 it starts 18, 19. Now you will be wondering why only 18 and 19 is being pasted over here. That's because when you do yanking, when you actually copy a specific number of lines, you can only copy it till the maximum number of lines allowed as 9. No two-digit line can be copied at a single instance. So for in this case, let's copy 9 lines and say paste it over here. Sorry, it's perhaps not working. Okay, sorry, it's 7 lines. Yeah, now it will be working. Okay, 18, then 1 2 3 4 5 6 7 8 9, and that's how it goes. And the other shortcuts will be like, if you have to move one particular space forward, let me open some another file for you. Okay, now if you have to move a whole word at a time, you can press, sorry, I'm in a off mood today. Okay, so if you have to move a whole character one at a time, you can press W. That will escape a whole word one at a time. Now if you have to like move one particular space at a time, you can press A, but as soon as you press A, it will get you into the insert mode also. Same wise, you can check for O, that will get you in the insert mode with a new line. You can use set NU, that will line all your numbers, the number of line you have in your document. Like for in this instance, we have 2 lines in our document. Okay, so that's how it's done. You can either use delete or X to delete some particular character without going into the insert mode. As for in this particular instance, it's asking for the document override because I haven't changed anything and I'm still quitting the file, so it will need a quit override, and there the exclamation mark is actually necessary. Okay, apart from that, just hold on a second, we'll have to pause it. Okay, sorry for the interruption. Okay, so that's what all the basic Vim commands were about. Now let's move on to the installation part. I'll be demonstrating it on the virtual machine itself. sorry, can't do it at all in the whole system at this time. Okay, so basically, when doing it in VMware, the VMware identifies the particular ISO as the Red Hat Enterprise Linux 6 and can do it for you with the easy install, but I'll be doing it all manually. Some few credentials is asked over here. Let's fill that in quickly. Sorry. Okay, no, let's do it. Okay. Now, if for in case if there comes a particular condition when you actually wish to install the system all of your own, but not by the easy install feature of the VMware, you can do it by removing this auto install.iso from the server configuration, and after that, when you will power on the virtual machine, it will start as some normal installation that would have been performed. Okay, so we wish to install or upgrade a particular system. Let it start. It will take a bit of a time, so let's have a bit patience. Okay, it's asked for sorry. Okay, so right now it's asking to check the media that we have, so that in between of the whole installation process there comes not any kind of error due to some CRC problem or some any other kind of problem. But I know that my ISO file is pretty good, so I'll skip it. Okay. It says that the local installation media is found. Not it. That means that the installation media is neither an optical one, or it's not over some network or anything like of that, but it's locally available on the system that's is installing the OS itself. Let's move next. The preferred language will be English itself. Okay, the keyboard I'm using is a US English keyboard only, so I'll keep it as that way. Now here what it comes is as it says that what kind of storage are you using. Now what these two particular option means is the basic storage actually denotes or defines the normal regular system hard disk that we use. Now specialized storage that can be chosen in case you're using some RHCSA storage or some over the network storage that you're using. It basically used in case of when you're installing in the operating system on some kind of a thin client or a network environment. So we'll be choosing the basic storage device. Next, it says that the hard disk that we are using has never been initialized, so till yet there's no formatting table available, so we'll ask to reinitialize it all. It asks for the system's identification, the host name that we want to set. Okay, so for instance, it's like one case say that the network I'm operating my system is of our Galgodias University. So and in the whole Galgodias University network, the system that we are using is of it's of like the Dean itself. Okay, so it to make it identifiable over the whole network, we'll set the host name likewise over here. So it will be like Dean dot Galgodias University dot edu dot in. That way, so when traversing through the whole network, it will be more easily identifiable. The system itself will be more easily identifiable. The system will be easily identifiable. Now if you want to configure the advanced aspects of the system, you can configure it right now over here, as like to which particular network available the system is connected. If it's connected to the wired network, the wireless network, or some DSL network, or is it connected to some VPN or else. Since my system is right now connected, is not basically connected to any network, though it's connected to a NAT network, but that's none of our concern, so we'll just go next. It asks for the root password, So I'll be providing the root password as, sorry, Redhat. It says that the password that you're using is a dictionary based password that can easily be cracked, but I'm good with it, so I'll choose the use anyway. Now here comes the basic partitioning options. Now there are five options in front of us that says by a, like, if you want to use all the space available on the hard disk, or if you want to replace the previous or the existing Linux system or systems, you want to shrink the operating system that's already on the hard disk, or you want to use the only available free space in the hard disk, or you want to create the whole partition table of your own. And below these, the two options that they're given is, if you want to encrypt the system, what it will do is it will encrypt the all users home directory on its own, so that no other user apart from root is able to view this system or the users directories. Okay, and below that it says that if you want to review and modify the partitioning layout, for in case if you're choosing the replace existing Linux system. So as for the demonstration purpose, I'll be choosing the create custom layout, but for your case, when you're installing, you can choose the replace existing Linux system. It's not much of a big deal. Let's go next. Okay, so what it gives over here is my 20 gigabyte of hard disk. It gives, like, and it's totally free. You can create whatever partitioning you wish to. Now before you get any further, uh, okay, let's keep it for the manager physical partition storage part 1 for now. The for installing a Linux system, we basically need 3 partition. I mean, you can create as many partition as you wish, but 3 partitions that are deep basic need of any Linux system, and that's only what we are going to create over here. We'll be creating a standard partition, not a LVM. I'll be describing what's LVM in our next video. So let's create a standard partition mount point. Now the 3 partition that are like the basic need of any Linux system are the slash or the root directory partition, the swap partition, and the third partition is the slash boot or the boot folder partition. These 3 should be there, and it's like not and it's like mandatory. It's nothing like recommended, but it's the mandatory 3 partitions that should be present on a Linux system. So it's like you should do it. Okay, so when it comes to the mount point, I say like uh, let me first create the swap partition, so that the rest of all space is left for my slash root partition. So it's generally told that the swap partitions should be the double size to what the normal available RAM of the system is. The reason behind it is that when swap partition is used, the maximum capacity of the swap partition as described by the IBM standards are that only 2 threads per actual RAM bit can be used for a swap partition, and that's the reason that the swap partition is said to be the double size of the RAM you have, or sorry, the RAM it's available in the system. So as for in this system, we have allotted 2 GB of RAM, so we'll be creating a 496 MB, that's approx 4 GB of swap space. After that, what we'll be creating is our slash boot partition of approx 200 MB. Let's say it's for like 1024 MB. Let's make it a GB. I have pretty much of a space for my system, so it's not an issue. and it's all okay. Create. Now let's create the root directory, and this time we'll allow the system to fill maximum possible space available in the hard disk. So let's go next. It says that the following pre-existing device have been selected to format and destroying all data. We'll say okay, it's not an issue, format it. Write changes to disk. The system is now reformatting the whole hard disk into the defined in the file system part, file system type, and in the define in mounting options. Now it asks for the bootloader. Now as we all know that the grub is by default the bootloader for the Linux system. Now so it's asking that on which particular hard disk, or which particular hard disk, or which particular partition you want to install that bootloader, the grub itself. So since our boot partition is in /dev/sda3, so we'll leave it as it is, and unless you have some real specialized system or specialized storage available, as for in case of a network storage or multiple hard disk scenario, you should leave it as it is in the default option. Now what here in this particular window it's asking is which particular kind of system that you want to install. You want to install a basic server, you want to install a database server, a web server, virtual host, desktop, software development, workstation, minimal. What it basically does is it on default chooses the best suited packages and the softwares for your system, and it install on its own. Now just for the demonstration purpose, we'll select the customize now, and we'll select the the desktop option. We'll go next. Now here you can actually on your own manually choose which particular package you want and which package you don't. There are various groups available here in which the similar kind of packages are grouped together. As for the basic system, these are the packages that you will be needing. Okay, for servers you have backup server, CIFS server, directory server, email server, FTP server, NFS server, and a hell lot of other servers. For web services you have real different options. So as I'll leave this on to you to explore all these options available. So let's for this instance go, and I'll choose customize later next, and that's all what you had to do to install your Linux system. And after that it will install the selected package for you on its own. So as for so till it's actually installing the selected packages and installing your Linux system, let's go through the particular point, the RAM architecture and the swap file system. So now understanding the RAM architecture is pretty necessary, is pretty important as to understand how this particular swap actually works. I've made a particular picture or a small demonstration to make it easy for you guys to understand how this RAM architecture works. So let's open it. So this is the basic overview of what a RAM is almost like, or how the RAM architecture is actually organized. What the RAM is divided into is 4 different parts. It's basically the kernel memory, the user memory, the workspace, and the cache and the buffer. Now what happens through all in this is when you execute a particular file that's I have shown over here in the white space. This is your hard disk. This is the file that you currently is executing. You have like given this particular hard disk space to the swap memory. So when you execute a particular file, the file goes into the ready queue, and before execution it waits into the RAM in the workspace area, that's this particular yellow area. And once and the CPU cycle is given to the particular file, the particular process. It moves from the workspace to the user memory, the green area, and there it goes into the whole execution process. Now, what the kernel memory holds is the kernel itself, the system file necessary for the kernel bridging, the device drivers, and the rest of the necessary operating system file itself. And as you all know, what stores in the cache and buffer are the regular used values or the regular used files. Now what happens over here is that for in a particular scenario, or for in some particular case, say a particular file is holding the user memory for a longer time than expected due to some IO wait or some other kind of wait queue it has gone into, and we are running out of the user memory area, when the user memory space. So that particular file will be moved into the cache and buffer till the operating system can hold it into over there. The moment sorry, the moment the user memory area will start overflowing and there will be no more available cache and buffer available to the operating system to move the particular files into, the what operating system start doing is it start moving the files available in the cache and buffer to the swap memory area that's on the hard disk. And from there, when that particular files execution cycle is recalled by the CPU, it loads back into the user memory area and the execution goes as it should, as uh, it should have gone. Okay, so that's the basic RAM architecture. Now going through the swap partitioning. Now there are two basic type of swap partitioning available. That's first the partition swap, and the second is the file swap. For in case of the partition swap, when the swap memory is actually a memory partition on the HDD, it's termed or it's called as the partition swap. And in case of the file swap, and a particular file in for the swap memory is actually made in the hard disk, but not a whole full-fledged sorry, not a whole full-fledged partition. As in case of the Linux systems, the partition swap is used, and when it comes to the Windows system, the file swap is used as when you actually increase your virtual memory space, or when you actually do the hibernating of your system, you actually can see a hyper file.sys and the C drive of your system, this particular file. That's this hyper file.sys and page file.sys is how the whole swapping process is done on a Windows system, and that's how what exactly is the file swap type, the file swapping. Now with all that done, oh sorry, I launched one of my game. Okay. Let's move. Sorry, just I beg your pardon. Let me terminate it. Okay. Okay, so let's move on to the next topic, that's configuring your system as an NTP server. That's a network time protocol server. Now what it does is basically when in a real-time scenario or in a network-based scenario, you need all your systems to be synchronized to one particular given time, to one particular time and date, so that the working and the logging of each system can be in like real time and correspondent to each other. So for that particular kind of service, the NTP servers are used, and basically the package for NTP server is NTP itself. So you can try like yum install NTP YV. It's always already installed in any system, either be a basic web server, a basic server, a desktop system, or even if the minimal installation option is chosen, it will be installed over there. The port that it it uses its 123, so it runs on the port number 123. The service it uses is NTPD, that's network time protocol daemon. So let's check if it's running or not. It's for now stopped, so we'll be starting it. So we have successfully started the NTPD server. Now, to make sure that every time our system run, the NTPD service is executed, what we can do is we can set its default execution, the default run level execution to on, and that can be done via the check config command. So it's chk config ntpd on. That same can be done for like any service. As for in the previous video when we studied the httpd service, we can do it the same for our httpd service, and we can even check for which particular services are available on our system and what's their current status. As for right now, here's the NTPD server that has been turned on for the run level 3, run level 4, and the run level 5, and have already okay, here is our httpd service which is currently off. So that's how it goes. Now to make sure that our the NTPD server is configured as it should be, or to configure it properly, what we will have to do is system config date. Sorry, I'm just not in my touch. Surely ask for your pardon because of that. Okay, so sorry, I'm doing it on the server itself. I must do it on the client system. I got it. Just hold on a second. Let me debrief you till then that what we are actually supposed to do. Now, for sure, we have to tick this checkbox over here that says synchronize date and time over the network, and in the over here in the add option given, we'll have to actually provide our servers or us in that particular system that we want to synchronize our time with IP address, and that's all. And after that, if you want to go for advanced options that goes by like speed up initial synchronization and use local time source, what it means is basically if you have provided more than one particular NTP server, as for in this particular case that goes like 0.rhel.pool.ntp.org, 1.rhel.pool.org, and so as like. So if you check this particular box, it will first opt for the most local time source, the most local server it's that's available to the particular system. And if you check the option above that speed up initial synchronization, then at the time of this system's startup, the system boot up, it will make sure that the synchronization doesn't take much of a long time and is synchronized as soon as possible. The time zones is for synchronizing the time zone over the network. Just hold on a second, let me show you. It's taking a bit of a time. Startup. I just don't know why it's taking so long. Okay, let's start. So here we have our sorry, let me check the network. So this is our server's IP address that will be feeding to the client. That's 192.168.214.128. So let's do it. System config. So now let's wait. And before we get any further into this, let's first delete this entry that I already have. Now let's change the date for now as like let's make it say what, like August 15th. It's like 11:28:38 set time, and we are good. As you can see, 11:28 a.m. It's August 15th. Okay, so all now what we have to do is let's click on this add the server's IP address. That's 192.168, sorry, 168.124.128, and let's go. Okay, let's wait for the NTP service to start, and that's all. Now if you want to do this whole process manually, you can do that even too, and the configuration file that you actually will have to edit will be a /etc/ntp.conf. Okay, so in this particular configuration file over here, below this particular one, below this particular line, you'll have to add that particular entry, the address of this server that you want to synchronize your time with. Right now it's not showing. Maybe there could be some problem. The service has not been restarted, or the server has not been updated, or something like that. So let's try restarting the service for once. Service ntpd restart. Okay, let's try if the configuration file is updated now. So how about we try a reboot? But before reboot, I'll like to check if my adapters are working perfectly. 192.168.214.1, sorry, 128, right? It's pinging very perfectly. Okay, let's try a reboot. Let's now just hold up for a minute. Till then, in the meantime, let me reopen my file that I had actually closed, so that I can keep a check on. Yep. So that I could keep a check on the topics. Sorry, let's see. Waiting the system to boot up. Okay, it says there is something problem with my system. It actually says that my hard disk is not has been not actually checked, so it's asking me to make sure that our partitions are checked manually. So that will take just a bit of a time. /sta1 enter. Yep. /sta2. Yep. Come on. Okay. Hopefully /sta3 is the boot partition, so it won't. Yes. Okay. Let's try the reboot. It's actually taking a bit much of a time than what I have expected. So let's meanwhile just check that what's your next topic. Okay, just commands. So while our client server no sorry while our client system is booting up, why don't we review through our commands? Okay, the commands that we actually are gonna study in this particular video are who, w, who hyphen r, run level, id, username, su, and then exclamation mark that I have already told you about, jobs, bg and fg. Now what exactly this who command does is it check for the user login status for each terminal. Now for as of you know that the whole Linux system basically works on terminal wise. We actually have seven by default we have seven terminals that are also called the TTYs. It's ranging from our F1 to F7. We can access each of our TTY by pressing Control Alt and any of the function key ranging from F1 to F7. The GUI basically runs on the F7 TTY, and the first boot up process that actually initiates the GUI or the genome is does actually run on the first TTY, that's on Control Alt F1. So actually if we press Control Alt F2, we will get to the TTY2. Okay, and same wise if you want to skip to another TTY, we can press like Control Alt F3, F4, F5, F6 till F7, to which will get the graphical display on which basically the graphical display works. But in this case, since the first TTY is initiating the graphical display, so you won't be able to access the F7 TTY. Okay, so basically the who commands is used to check the user login status for terminal. Ouch. Ooh, sorry. Yeah, there we go. Now what does W does? Well, W more or less does the same thing what the who command does, but it actually gives us some of more informations than what who command actually can give to us. So basically it's this. Yeah, basically it actually provides us with more information regarding the user credentials and each and everything with the above information available. Now what does who hyphen r does? It return back you your run level, the run level that you are currently working on. It returns you that. What actually are run levels? Well, we'll be discussing that in some other video. The run level command itself does the same. It's just the alternative. Whatever suits you, you can use it. Now as stated by the name itself, id hyphen username gives the id, the user id for any particular user, the uid that's set. And the su command is basically used to switch user from the current user to some other user. And as for in case if I'm logged in into as root or as admin, or as in this case let me see, okay, or as in this case if I'm logged in as the client user, and I want to switch to uh, like say I'm logged in as the client user and I want to switch to the super user. Now I can use this su command in the terminal, the su command in the terminal, and I can directly log into the next user or the as the root user through the terminal without having the the problematic way of logging out and then relogging in via the GUI as it's in the Windows. And there is actually one more thing that I wish to tell you about the su command, but let me explain it to you. Let me write over here. Basically first, Yeah, basically when you actually use the su command, the only su command, it will use the previous user's user environment and working directory, the home directory, and each and everything, and will just in the present working directory will switch to the, it will just switch back to the new user. But if you use it with su a space and then just a hyphen, no other word after the hyphen but only and itself just the hyphen, well, you can switch to the new user uh, with the new user's own user environment and own working directory, the home directory, and the rest of the credentials. Okay, so now as I've already told you, the exclamation mark, it's actually used to repeat any command based on the command name given or the command number, sorry. Now there is a thing that how one can get the command number. I'll be just showing you how you actually can get the whole command number from your history command. Okay, so let's just hold on for the, let's just hold on to that for a moment. Now what the job command does is it shows you all the background processes, the all the jobs, the processes that are running into your system. What bg does is to send a particular job to the background. What fg does is to bring that background process back to the foreground, and that's all it does. Okay, so let's log in. Now I just don't want to log in as client. I'll log in as root. Sorry. Fish. I wish to show you the logs for the boot up process, in which it will be shown that it's actually the NTP's AD server is actually rebooted, restarted, and there it is. The system has updated itself. Sorry, the system has updated itself to the recent time, whatever the time it is. As I have, sorry, as I have updated my adapter of the Windows. So, due to the time zone shift, it's actually showing you the wrong date, but it has updated itself from the time. Just will will like to pause over here a bit. Sorry for the interruption, guys. Uh, See, I seriously apologize for the interruption, but uh, happiness some of the issue. So that's actually goes our NTP server. Do try it at home and let me know if some problem comes. So with that, we'll actually power off our client system and let's go back to the server system, the main system. Okay, so the next topic is managing physical partition or physical storage part 1. Now this one particular part of it is in particular doesn't contains much of the practical or much to show you about, but instead it's more of like the theory part. It's basically about um, how many kind of what are the types of partition that you actually create on your system, what particular partition is meant for what particular purpose, and the basic overview of actually knowing your partition or knowing your physical storage. So let's do it in them. Sorry, I don't know if the spelling is right or not. Just let's start. Okay, So basically, when it comes into the managing physical partition or storage, part one of the RHCSA. It's actually the topic of the RHCSA. When you get into the modules of RHC, or basically, sorry, of the RHCA, this particular one topic comes into the book first of the RHCSA. Now basically what it talks about is how many kind of partition you actually can create on a system, and why you can create it, what are the the basic overview. It's something I myself never interested in, but since it's one of the part of RCSA that you must know, um, like um, I have to cover it. So sorry for most of most of in the part I'll be going through the theory. So let's start. I'll be so I thought it will be better to write so that it's less boring. Okay. As we all know that the PC or the system that we right now use are basically made on the IBM PC standards, the standards that are and that IBM has actually set up for the PCs, the motherboards, or the software hardware vendors. So basically, when the hard disk were like new innovation in the market, IBM at the time set the constraints that in a particular system there can be a maximum number of 15 partitions. Okay, so how only 15 partition can there be in a particular system? So when IBM PCs used to ship with Microsoft Windows, of course, in the early times, it was 1970 or 1980s, the IBM PC storage is basically defined on these particular parameters that were uh, 15 type of partition. Sorry. Sorry, I know it must be feeling boring, but it's total theory, and when it comes to theory, I just don't know a better way than this to demonstrate or to explain it. It's plain theory, man. Okay, so basically, as defined by the IBM PC storage management, the spelling of management is wrong. Yes, sorry. Okay. As defined by the IBM PC storage management, there can be a maximum of 15 partitions at that particular time in a normal system, in which there can be total of a primary partitions that are actually. What's the difference between primary partition and the rest of the partition is that the most probably in like shorter overview condition or shorter overview elaborate. explanation. Primary partitions are those particular partitions that the operating system can actually map continuously on a particular track and sector of hard disk. And there comes the extended partition. What extended partition actually contains is actually works as a container, or a whole universal set for the upcoming logical partitions. And within this one particular extended partition, you can make up to 11 logical partitions. That was something like what IBM PC storage management stated. But in now particular days, there are even ways that you can work around this limitation and make up to as many as you wish logical partitions. Not, though the maximum number of primary partitions that you can make is still only 4. Extended partition you can make only 1, as far as I know. But yeah, you can work your way around and make uh, more than 11 logical partitions, so allowing you to make as many as partitions you wish. Now there is one particular thing on the hard disk that actually helps your system to boot up, and that's the MBR, the master boot record. Now let's talk a bit about the master boot record. Master boot record. It's 512. Sorry. Okay, it's 512 bytes in total. So 512 bytes look a lot. I mean, it looks a lot less. Looks a lot low when it comes to like uh, hard disk, or when it comes to storage matters. But uh, believe me, what the information that MBR stores, and the information that is actually needed to be stored in the MBR, well, 512 bytes is more than enough for that kind of information. Because what actually the MBR stores is it's basically 446 byte for the bootloader. Okay, what bootloader holds is the information about on which particular track or which particular sector of the hard disk the operating system is stored from, where you will find the necessary information about the actually the pointers, the memory locations from where you can actually start reading the information that you'll be needing to boot up a or boot up the particular OS. Okay, so apart from this, it contains 16 into 4. That's 16 byte for each primary partition, since we can have only 4 primary partitions. So 16 into 4, that's byte partition. As stated by the name itself, what it contains is the information about your partitions, that from which particular track and sector your primary partitions are starting, and on which particular track and sector it actually ends. Basically, it only holds this particular information about the primary partitions. Now, if you remember your C class, if you remember the C language, your basics of the C class, you most probably will remember that integer, it used to store I mean the total memory needed for one particular integer to store is exactly 8 byte. So that basically not it was 8 byte or 8 bit. No, I'm pretty confused. It was most probably 2 bytes. Yeah, it was 2 bytes. It was 2 bytes, and for long it was 4 bytes. Yeah, so basically it's a long time. Voila, sorry. Okay, and if you're going through all the calculations right now, you probably would have guessed that 2 byte is missing. Now this 2 byte is known as the magic number or the partition signal that actually sets that what particular number of partitions are available in the system, what particular number of partitions the MBR or the bootloader have to search for, and that's what it holds. So this 2 byte is the magic number or partition signal. Okay. Now the 16 byte that actually is used to store the information about the primary partition. It, apart from holding the starting and the ending location of the primary partitions on the HDD, it actually holds some more information. It actually holds the information in form of integers only. Okay, so don't take me as wrong that I was in annoying and I was trying to hit some arrow in the dark with some blind shots. Okay, it actually holds the information in the integer forms only. Now apart from the starting and ending location of the partition on the HDD, what the different values, the extra, yeah, extra was the word I was trying to find. Yeah, exactly, sorry. Okay, so the extra information that it actually holds on, the extra information it actually stores are the size, the type, the file system type, the mounting, the mount point starting, and things like that, that actually is needed for a file system to work. Actually in this particular 16 byte, it actually holds all this hell lot of information about that one particular partition. And on the last, it actually holds the partition, it actually holds the information that leads to the next or the magic number or the partition signal. Okay, so with all this partition going, there comes a basic question, there comes a basic query that that's actually up to you. Putting this question, it's actually a pretty easy one, and actually I was supposed to answer it, but I'll be putting up for you. Okay, why do we partition, or why do we need a particular partition? That's the question that you will actually have to deal with. Now before we get any further, there are just a few more things that I have to actually explain in this particular topic, and that's in the Linux system, the hard disks, the storage device that you actually use, there are basically of three, basically that we use is of two types. Either they are ID drives, or they are SCSI drives or SATA drives. Sorry guys, again sorry. Okay, so if you have some IDE drive, okay, that's goes in particular for IDE hard disk, the your particular hard disk will be shown in the /dev folder under the name of HD and X. Now what's this X is? X is the particular alphabet. It can be A, it can be B, it can be C, depending upon the number of IDE hard disks you have into your system. Like if I have 3 IDE hard disks, my system will show HDA, HDB, HDC. And if it's like I have 3 partitions in my HDA, or my first IDE hard disk, then I'll be saying HDA as for the whole hard disk, and then after it I will be seeing HDA1, HDA2, HDA3, denoting the 3 partitions in the first hard disk. Now if I have like say 4 primary partitions, okay, and then 3 logical partitions in my second hard disk, okay, then what I'll be seeing is the hardest type is IDE. It's IDE only. So what I'll be seeing is HDA, no, sorry, HDB. Okay, that's for the whole hard disk, and then I'll be seeing HDB1, HDB2, HDB3, HDB4 for the 4 primary partitions, and after that for the 3 logical partitions I'll be seeing HDB6. We won't be seeing HDA5 because that particular number 5 is reserved for that one extended partition that you have created. Okay, and since it acts as the whole container for the logical partition that actually used, so you actually does not see the HDX. Better, I actually prefer call it X rather than a specific alphabets. So HDX, instead of HDX5 you will be seeing HDX6, HDB6, HDB7, and HDB8, and so on. For in case like now we in our systems doesn't have an ID device, be it the optical drive, be it the hardest, we don't actually now have an ID device, not even in our desktop. Forget about for the laptops. The reason for, because of the reason for that is basically ID device used to, you know, it actually use a hell lot of power consumption, um, and it actually needed a pretty big interface to connect. So that was a whole lot clumsy. A big interface means a hell lot of wires, and that actually at the end of the day used to increase the cable clustering and each and everything. So the researchers and scientists decided to actually shorten the whole interface, and they made this new interface that's called SCSI. That's the abbreviation, that's the short form for small component, sorry, that's secondary component small interface. Yeah, secondary components small interface, and or the SATA, that's the serial ATA connection. Okay, so in so like nowadays when it comes to your sorry, so nowadays when it comes to your hard disks, you will be seeing it as slash dev slash uh, I don't have ST, sorry. Okay, I need to do an ls. Ouch. Sometimes I act like such an asshole. Okay, this is how you will be seeing it in your system. SDA, since I have only one hard disk and I have only created 3 partitions, so SDA1, SDA2, SDA3. That's how it goes. And with that, this topic concludes. Voila. Thank God. Didn't it? Okay, now come an interesting topic, that's symbolic links, are in short called as symlinks. Now basically what symlinks are, to demonstrate it, I've already made a demonstration for you. That's a picture for you guys. So let's minimize, have it converted. Sorry, let me start the convert. Okay, and we will be needing MS Paint. Sorry, control open. Da 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 da. Yep. Tada. Yes, this is the right picture. Okay, so symlink. Basically, when it comes to like in Linux, you can actually create linkings, as in case of Windows, we create shortcuts, same, more of like kind of same thing that we can create in Linux, that's called symlinks or symbolic links, the long form for symlinks. So now basically how a user, the for those who have already studied operating system or software or system analysis design or software engineering or computer organization or architecture, they knew about it, that they always is two basic view for a computer or for any system. That's one is the user view and one is the system view. Now when it comes to the system view, the system views the whole files and each and everything as streams of data and as what's called memory addresses, nothing more than that. When it comes to the user view of the same, the files, the data, the user view is in form of files and folders and hierarchy of directories and each and everything like that. So it's this one particular complex problem, that how that particular system view is converted into this particular user view. And this is the one of like the most simplified diagram, picture, whatever you wish to call it, for that. Now what actually it is happening over here, let me explain it to you. Let me check. Okay, my mic is at the right time, at the right place. Okay, so the white area in the picture, over here in the black area, this is our particular file that we are supposing, or we are actually demonstrating this whole picture through. So this, the file and the memory address for this one particular file is sent back to the kernel. The kernel is basically it's a part of an operating system that actually acts as the gateway or the mediator between the whole operating system, the software and the instructional thing, the codes and the commands that you actually enter, and the hardware. Now basically what it means, that as all of you know, that what our hardware, what our electronics understands as basically 0 and 1 only. So it's basically the work of our kernel itself to make sure that the right command goes to the right piece of hardware and is returned from the right piece of hardware to the right piece of software or the program. So that's what basically is the work of the kernel. Now I'll get I'll get back to you on that. Okay, so just like on one of the most basic overview of the whole operating system, or the whole operating system and hardware relationship, if we try to sketch off, can be like this. Let me try if I can. Okay, okay, it will be like users. Okay, users. Okay, this whole big particular circle is our application. So let me mark it, application. Okay, and what is application? Well, this one particular thing is our application. The user interacts with the application. Okay, the application then interacts no, sorry. Yep, the application then interacts with may need to increase it a bit. Okay, that should work. Okay, the application then interacts with what we call as shell. Okay. Now what this shell is exactly, a as if sorry, as if in case of your Windows, it's the Windows Explorer. As if in case of my Linux, it's the terminals. The bash shell, that's actually the short form for born again shell. Born is not born, it's bourn. Born ultimatum, born identity, born supremacy. That born, that born actually. Okay, this shell, okay, it actually communicates with the kernel. Okay, it's communicate with the kernel. Pardon me if the spelling is wrong. I'm not very good with the right spellings. Sorry, and sorry. Okay. Um, Needless to say that the arrows that I'm sketching or drawing right now is just like to indicate the one path or the one way of the whole communication that actually takes place. It's the arrow basically indicates a whole two-way process or the two-way communication. Okay, now the kernel interfaces with the any guesses? Of course, it's obvious. That's hardware. Okay, so now what it does is simple. Sorry, yo. Okay, so now what happens is the user sends a particular request to an application, the application forwarded to the shell forwarded to the kernel forwarded to the hardware execute and process it and do all the ALU and blah 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 hell whatsoever, return back the output to the kernel encoded back into the command form or the human readable form, return back to the shell then then recall itself that okay, this one particular output was for which particular application. It reminds itself that okay, it was for that particular application, and then it sends that output back to the application, and hence the output is shown to the user. So this was cancelled. Okay, don't save. Okay, now open. Anyway, so this is how all it happens, and the same is what happens in the case of converting this system view of a file to the user view. Now what actually happens over here is the memory address of the file is sent to the kernel. This kernel sends back the virtual address, and that's actually in kernel in modern day computers or in the modern day operating system never tells the shell the applications the actual memory location or the actual memory address of any file, any register, or any particular memory value. It never tells you the actual memory location, and that's how the paging and the swapping and the virtual memory addressing is done. That actually allows the kernel to address more memory that's physically possible. I mean, if there are 100 memory possible, if there are 100 memory locations available, it can be that with proper optimization and proper uses of the virtual memory addressing, the kernel can be able to like memory address 200 different values at a time. It can. I mean, it's just an like a rough overview or rough what do you say? I just don't remember. Just can't recall that particular word. Um, it's like just a rough sketch of what memory addressing is capable of and how it works in the modern day computers and the modern day operating systems. Okay, so the virtual address is sent back to the shell. The shell stores the virtual address as inode, and that what is inode? Just don't remember. It was we'll have to refer my book for that. I just don't remember what inode it was. Just can't remember it. Okay, so it stores the virtual address as inode and shows the particular file in some fancy graphics back to the user if you're using the GUI, and if you're using the terminal, it shows in the form of text as it shows. Okay, so now symlink, what we were talking about. Okay, so as I stated you that there are two types of symlink. Basically, there is this hard link and there's this soft link. So now what happens in this form of the soft link is basically as we create the shortcuts in case of our Windows operating system, like this. Sorry, it will not be shown over here since I've already let's see. Okay, how about if I create the shortcut for my Tekken game over the desktop. Okay, so just like for demonstration purpose, let me show it to you. View desktop icons. Right. Okay, so as we can see that we don't have the shortcut for the Tekken game. So don't show the. Okay, so we are creating the shortcut. What we all do is right click, send to desktop, create shortcut, and the shortcut is created. That's how we create the links or the shortcuts in case of Windows operating system. Yeah, you just can see. Okay, just let it be. Let me show you. Okay, here is my Tekken shortcut that I recently created. I just don't need it, so I'll remove it. Okay, that but it's basically soft link. Let me demonstrate it to you. What soft link does is it creates another file. Okay, it creates another file that actually copies this particular virtual address or this particular inode number into itself. Sorry, into itself. Yeah, and that's what exactly is soft link. Now in case of soft link, if the actual file is deleted, the soft link goes useless. That's actually how soft link works. If the actual or the original file is deleted, the soft link will not work. The soft link just doesn't will work, and the link will be broken and it will be useless. Okay, so what actually we does in case of deleting a file is that we just remove this one particular inode number. Like let me sorry it's just like we delete this particular inode number. Now we have deleted the particular inode number, so the user is not able to view the that the particular file is available over here in the memory, but the file remains over in the memory till the operating system doesn't need that particular space. And till the operating system doesn't need that particular space, it will remain there over in the memory, claiming its space, claiming its area. Okay, so that's how it actually is, and that's how it's done. Okay, and this is how softlink works. I'll be demonstrating you how the softlinks are made. Just hold your horses. Okay, just hold your horses. Right. Now what happens in case of hard link is that this virtual address is actually copied to a whole new inode number. Okay, that new inode number, in case of the softlink, the previous inode number was stored in the softlink, and on the previous inode number the softlink was working. But in case of the hard link, the virtual address is actually stored in some new inode number, and that new inode number is then copied to the hard link memory location. So even if in that one particular case, if what we do as deleting the file, even if you delete this particular old link or the inode number, it won't affect the hard link, as the actual virtual address of the file present in the memory is available to the hard link in form of a new in form of some whole new inode number, and that's how it works, and that's it is. But matter of precaution over here is that, as I've stated you, that the soft link will copy the previous inode number of the file into its memory location, and it will point to the previous inode number. So a soft link won't take like much of a data. On a max it will take like a byte, nothing more than that. But in case of hard link, it actually will take it actually will show or possess the actual total size of the whole data. Although that there will be no data redundancy, there will be no data duplicacy or the data copying, but it will, for the user view, for the shell view, the shell view of the operating system, for the operating system view, it will actually capture that. It will actually, like, hold that particular amount of data, even if the old inode link is available there. So actually, for the operating system, there will be like twice the space used in case of hard links. Now let's see how we make one hard link. Okay. So in case of let's see first hard link. Guys, we'll have a setup break after this, so just be prepared. Okay, in case of hard link, ln is the command. What all we need to do is ln space the original file name and the link name as text. mm, Hard link to txt. Let's just see if it's actually made. Okay, we have actually created a hard link to the txt, and if we do an ll txt, it's of actually 2 byte. It's also of 2 byte, and if we try to view it, let's cat actually compare is there, like what was the command for comparing? It was I just don't remember. Okay, leave it. Cat. That was actually a better command. Okay, leave it, man. Okay, cat txt, and let's cat hard link to txt. Okay, both jet set go, both jet set go. Did to. I'm just not able to remember what is the particular command to compare two files, so I'm actually unable to demonstrate it to you. Let's check if I can remember it on them. Sorry. Okay, so yep, man, in the WIMP module of this particular video, I just forgot to tell you this. If you need more readings or any kind of particular help regarding WIMP, as I need it in this particular moment, you can use you can use in command mode H or help, and it will get you to the help text. Okay, leave it. I'm just not demonstrating. It's basically the same. If you want to, like, why I'm doing this. Okay, so these are basically the same files. Believe me, it is. And if you don't believe me, then probably okay, yeah. Okay, then probably you can try it off your own and tell me if any kind of differences come. Sorry, difference come. There's nothing like differences. Okay, so let's test Okay, so that's hard link. Well, in case of soft link, there's nothing of much of a rocket science to it. All what to have you do is add an -s, and that's tada 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 soft link to the txt. To do, as you can see, this one particular shortcut icon over here, and when it comes to the hard link, you can actually see a new it looks like a whole new file is made, containing almost the same data as the previous file, but in this case this one particular shortcut appears over here. Now if we do an ll, you can see actually the difference, that this soft link thing actually directs that this one particular file is actually it does actually take only one single byte, and is not the original file, but it actually points to this particular file. But when it comes to the hard link to the txt, or the hard link, it actually shows as it's a whole full-fledged file. Yeah, and you can see it's like if you want to check for the specific uh, size occupied by these particular links, well, it's here 3 byte, 331 byte, 331 byte. Bingo. So with that done, we'll take our sutta break over here. Sorry for the interruption, but I'm actually not really sorry this time. So sorry for my don't say it. Okay, sorry for my mocking. Okay, sutta break time, guys. Catch you in 5. Okay, guys. So sutta break over. We are back now. My roomie is actually screaming out on me in sign language for the cooler being switched off for so long, and since the video has actually gone pretty long, it's already have been of like 30 minutes previous and 56 minutes this, so it's already have the video already have been of like an hour and a half. So I'll actually wish to cut a bit short this time, and we won't be doing a few topics in this video as promised. So this particular video we'll be doing it till the file permission, securing Linux file access only, not over that. So let's start. Okay, so basically when it comes to the file access restriction in Linux, we basically have to interface with three different kinds of modules, or three different kind of permission that has been given to us by the Linux. That's actually first comes is the basic read write execute permission. Now what read write execute permission is, let me show it to you. As you can see over here, we have some bits that is being there's some information basically that is being shown to us. This basically indicates the read write and execute permission in three different groups. Sorry, yeah, three different groups. The first group basically it shows for the owner itself, the owner who created the file, the permission he have on that particular file. Then it shows the users that is in the same group as the owner who created the file, and the last three bits shows what the other users or the other people that are neither the owner of the file or not in the same group as the owner of the file are yeah, their permission. So it's basically like read write execute for the owner, then it's read write execute for the group users, and then it's read write execute for the other users, the users apart from the owner and apart from the users that are in the same group as the owner. So basically it's read write execute. Now what read write execute is, what it means is there's basically is constrained over its name only. The read permission means that the permission given to the particular user or to the particular group of users can read that particular file, can view the contents of that particular file. The write permission gives them the authority to alter or change that particular file. The execute permission gives them the permission of able to execute that particular file. Now what it means is this particular execute yeah, this particular execute permission, what it means is basically say I create a basic shell script or any kind of executable script. Let for in case say I created hello world.py. Okay, let's say that we are creating some hello world script in Python. Okay, so let's make that particular script equal hello world, and that's no, that's not all. Actually, we'll have to define the sorry. Actually, we'll have to define the interpreter or the compiler for it. So that will be Python enter and blah blah. One more file to edit, and yeah, it's done. So okay, I got it. What it meant. So now, since I've given a space between the hello and the world, so basically it took as two different. Basically, it took the hello and the world as two different files. So we will be actually needing to rename it. So let's rename it. And we have okay, hello to hello dot py. Okay. Ta-da! Now, when we check for the when we check for the properties of that particular hello.py file, it doesn't shows that it shows that we don't have the execute permission on that particular one file. What it means that when I try to execute the hello.py file, it will say permission denied, because even the owner doesn't have the permission to execute this particular file. Now let's try this twice.py. Let's say some invalid syntax, most probably missing a semicolon. I'm not a Python programmer, I just don't know Python very well. Yeah, shit man. Actually, let's move it to trash. Empty trash. Empty. Okay, sorry. Let's say, okay, let's try to add it. I just don't know what I'm doing. Just read it somewhere, so I'm trying it. Still says invalid syntax. I just don't know what it means. Okay, just leave it for the time being. Let's change it to mv hello.py to hello.sh. Let's try to edit it. Oh shit, I don't have any such files. Shit, and the night's getting on me. sh, right? No, it's bash. And when it comes to bash, we don't, we actually sh, hello world. Okay, good. Okay, so now again, hello.sh, we don't have the execution permission. So unless or until we actually provide the file to the compiler itself, we can't execute it unanimously. I mean, if we try the // command, that's basically for unanimously executing any particular script any particular, yeah, script or any particular program or any particular binary file. Basically it won't execute since we don't have the permission. So uh, in order to that, yeah, in order for, if we want to grant the permission, we can use the chmod command. Yeah, it actually sounds a bit awkward in that sense, but it's basically chmod. Sorry, it's basically chmod. And let me tell you now one interesting thing. Now you can actually define the permissions in two ways. You can actually define it the long way. That's you can actually write rwx 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 for respectively all the work groups, the owner, the group, and the other and the others. Or instead you can use the overall, you can directly use the bit parameters to use this, as for example the read permission. It holds the it actually sets the uh, um, how to explain, the read parameter actually holds 4 bit, it actually it's set off by what do you say, setting 4 bits on in the file permission area for the owner, or for whatever group you want to set it. The read parameter actually means it will set 4 bits on. The write parameter will set 2 bits on, and the execute parameter takes 1 bit. It's like a boolean on or off. Okay, so combining all these three, any group of users, either be that owner, either be that groups of the users the owner is in, or the others group, it actually can take a maximum value of 7 for the regular file permissions. So now if you if for in case want to provide myself the execute permission, now what I can do is I can either use plus x, that's for adding execute permission to the user, unless or until I specify over here in which particular order or to which either group or the others I want to associate it, to grant it, if I actually wish to grant it to, and then the file, and that's exactly like yeah, hello, that will set the execute parameter on in all of the available users domain, either it be the uh, groups, or either it be the others, or either it be the users. It will set the execute parameter on in all three of these domains. Okay, so now if we want to do it specifically for the user, we can do it like chmod 755. Now what 55 basically denotes is, as you already know, as you must have actually what's that word, predicted, yeah, sorry, as you must have already predicted, it's for like provide all the permissions, the read, write, and execute. That's the 4 bit plus 2 bit plus 1 bit, that's total 7 bit. 5 bit for the group, turn 5 bits for group on, and turn 5 bits for others on. Now that means that I'll be providing the same permission that the file has right now again to it. So now for in case we only want to provide the execute permission to the owner, we can turn the bits like 744, and when we do enter, we can see we have the only the owner's execute permission bit is set to on, and the rest groups and the others execution bit is turned off, and that's how it goes. Okay, so now let me tell you what this whole area over here specifically means. Okay, let's open up your file permissions. Okay, so basically what you see is like this. It's hyphen rw tada 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 tada. Okay, this is what you basically see in any file permission case. And on some particular cases you can see it like tada 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 tada. That means that all the three user domains, the owner, the groups, and the others have all the permissions available. Read, write, execute, read, write, execute, and read, write, execute. But then it comes to this one particular conclusion, and it boils down to one particular thing, that what the hell the first bit holds. It actually holds the information about what that particular file is, or the particular entry that is being shown over there. What is it actually? The possible values it can store or show is it's a dash or a hyphen for regular files. It will show D for directory, L for symlinks or softlinks, C for character device, as for example monitors or terminals that actually gives you back the output. uh, it will show B for block device, as for example in case of pen drive or DVD drive or USB drive, such drives that can basically do an IO operation. P is for pipeline or for socket files, and S for specific socket files. Sorry. So basically, P is not for socket files. P is basically for socket information. But let's consider it only pipeline. Okay. So let's delete it. We'll do a Q. Sorry. Let's see if Q is allowed. No, Q is not allowed. Ta-da, ta-da, ta-da. Now let me show you that actually these things that I recently told you does exist. For that, let's get into the /dev, because that's the only folder that contains the most variety of available files in the whole system. And let's enter. Okay, this is okay. So this one particular block entry that is shown over here is directory. This one particular entry that shows C in starting is denoting a character device. Okay, let's find a more yeah, as you can see, console C, that's basically for character device type for the terminal. That in other languages is also called as console. Okay, you can see the soft link as the one we have created. Let's demonstrate it. Soft link to txt, it's L. Regular files, it's only hyphen. Okay, and let's see if we yeah, S. S was socket files. Okay, so we got the S type of file to, we got the B, that's block device type of file to, that loop devices, such devices that send back the whole information back to the system, not to any kind of some specific device. It's loop devices are basically used to test some particular kind of device on the system itself, not so that that particular device is not is being necessary in its physical form to yeah, it's being in necessary or is made available in the system for, physical form itself. P will have to search for the P type of file or the pipeline type of file, because that's a really rare one and we are not able to see it. Sorry. Okay, T2Y, as I have explained to you, yeah, for sure, we can extend it from F7 to like hell anything, as you can see over here. It's till T2Y 6. It shows C, that character type of device file, that basically shows you to the shows you the output, and that's bingo. Anything else? No. Yes, one thing more, and that's spatial permissions. Now, what are spatial permissions? Now, there are basically three types of spatial permission. Now, where is the spatial permission is shown again? Any guesses? Okay, I'll let you guess, but since you can give your feedback or your replies to me, so I'll be telling you where the special permission is shown. And basically, this special permission is always shown in a bit, yeah, a bit preceding the regular file permission. Let's see if I can demonstrate it in case of this. No, it's not available over here because the setting is not showing in the form of setting file or such one. Maybe now. Maybe okay, open. Okay. Sorry. So basically, we have when it comes to spatial permissions, we have three kind of spatial permissions that is being provided to us. That's sticky bit, SGID, and SUID. Now, what sticky bit means is if you want only the owner to be able to delete file, the file that is being created, if you want only the owner to be able to delete that one particular file, not anyone else, that is not anyone any user from the same group the owner is in or anything like of that. So you can set the sticky bit key on so that the only the owner will be able to delete that one particular file. It is understood that no matter whatever you set, until unless you explicitly set the ACL list, uh, the root user will be able to delete any file he wish. So that goes unsaid. Okay. Apart from the sticky bit, there comes the SGID, which the basic function of SGID is to make the directory group to be inherited by the subdirectory instead of the owner privilege. That means if it's like say I make a particular folder common throughout the network, okay, and I've set the group of the folder, the group that the folder belongs to be for the CS department, but the folder is accessible and writable by all the departments available. But I want that the files that are created or the folders that are created into that folder should be a part of the group the fold and the parent folder is of. So I'm not able to explain it. I mean, I feel as if I'm not able to explain it too more clearly. I'll try demonstrating it. Sorry, no, not really. I'll try demonstrating it in the MS Paint. Okay, so it's like we have a folder, right? And we make like certain files. Sorry, make certain files. It's like file 1, file 2, file 3, file 4, file 6, file 7, file 8, file 8, file 9. Okay, so let's say that this particular folder belongs to the group computer, no, by computer science. It will belong to the group G.A.N.G. Yep, it will belong to the group G.A.N.G. And but this particular folder is accessible and writable by anyone over the whole network, even by like others or by the guest or by like anyone. Okay, but I want that all the files, these files that are created into this particular one folder. Let's say that we have three users in our whole network. That's say our dean, our program chair, and our coordinator. Okay, so uh, apart from the members of our group, the gang, these three users are there who can actually access this one particular folder. Now what I've want is no matter who of this three users create the file into this one particular directory, the group for this and the group for this the file that is being created into this particular directory should be the gang itself. Like if we say the dean Just hold on a second. Let this text me is something over on WhatsApp. Let me reply him. He says good night. I says video bana raha hu. के साथ कहानी का. Okay, sorry for the interruption. Okay, so now let's say the dean is fetch. Sorry, no, the dean is not fetch. Sorry, pardon my language. Tada. Okay, the dean is of group say X Y Z. The program chair is the program chair is of the group ABC, and the coordinator is of group MNO. Okay. And we have our okay, we have our users. So good morning रे, मैं गिर रहा हूँ. Okay, जाना, सो जा, सो जा. कल मीटिंग में जरूर आ जाना. Need something important to talk. Go, Nitish, go. Okay, so the users available in the gang group is Siddharth, Nitish himself, me, Ashwar, yeah, and Ankit. We are missing Ankit. These 5 belong to the okay, let me use the plus. I'm pretty bad at points. Okay, these 5 particular users belong to this one particular group, that's gang, and that's the name of the folder too. And these particular 3 users, Dean, Program Chair, and Coordinator, belong to this particular groups XYZ, ABC, and MNO. Okay, so what we want that the file created in this particular one folder should belong to the gang group only, not to their respective group, that's XYZ, ABC, and MNO. So for that we can set the SGID bit on, and as we set that particular bit on, let's demonstrate it. Let's make an encoder SGID. Okay, lol. Okay, it says that there's the D. Okay, SGID is a folder. We can check that with the D bit on directory. Okay, the owner is root, the group is root. Since it's a folder, it will take 496 bytes. That's exactly 4 byte, I guess. Yeah, it's 4 KB. Okay, yes. It's actually 496 byte, so it's 4 KB. Yeah. Okay, that's a lot of things. Okay. So if we set the SGID bit on for it, let's set the bit on. Okay, actually I'll be demonstrating you how to. I'll be telling you how to respectively change these whole 3 bits, the sticky bit, the SUID, and SGID bits. But just for the demonstration purpose, hold your horses. Ta-da! To let's say 777. I don't care. SGID. Ta-da! Let's make some users. User. No, I already have a user. His name is Joe. Sujo, as I've already told you, SU is the command for switch user Joe, and I'm switch user. Sorry, I'm not switch user, I'm Joe. Okay, so now LL, and let's change that to touch ABC. LL look now, uh, groups Joe. As we can see that the Joe user belongs to only one particular group right now. That's the user Joe. Okay, but the file that is right now created by the user Joe in the particular folder as GID, the file A, B, and C is actually a member of the group root. That's what actually SGID does, and that's what I'm actually trying to make you understand. Okay, just for the demonstration purpose, let's make another getter. No, SGID. Okay, ch mode 777. No, SGID. Okay, CD. No. So here you can actually see the difference now in the no SGID folder we are right now, as we are in right now. The very same three files made by the very same command touch abc is the owner of this particular file is Joe, the group is Joe, but in the one particular folder that we have set the SGID command SGID bit on, the owner is Joe, but the group is root. That's how you can actually retain the permissions set for the group users on some particular uh, folder or directory. That's where it comes really handy. Okay, so that's how it is, and that's what it was about. And anything else that I wanted to let you know about SGID? Yeah, one thing more, that SGID, as you may already have noticed, works only on the folder. I mean, you can set this particular bit on some particular folder only. You cannot set this particular bit on some particular specific file. It's a folder only permission. It's not a file based permission. Okay, let's move on to the last of our special permission, that's SUID. And SUID, what basically SUID is, it's basically to grant some user privilege of some other mm, user. It's like if I set SUID bit on of some particular file that's actually created by the root itself, and if my user Joe will be executing or will be working on that particular file, if I have set the SUID bit on the when that particular file will be in execution by any user apart from root, that particular file will be operated or will be executed as if it was being executed by the root itself, and that's what is SUID does. Now, just to wrap it all pretty fast, I won't be explaining you the ACL. ACL comes in the next video. Sorry, I've already made the video hell too long. Okay, it's 2:42 already, and I have to get to the college tomorrow. So sorry. Okay, let's come to our topic now. And sticky bets actually take takes value in the bets for only it actually holds only one bet. It actually takes only one bet to set its permission on or off. SGID takes two, as you already have noticed. It's 277, so that 2 was for SGID, and 4 is for SUID. So basically, if you want to set the special permission bits on the all three special permission bits, the all three file access permissions, and each and everything on, if you want for some particular folder, you will have to do 4 times 7, that's 77777. chmod is your command, and with that IRS will take a leave. Goodbye for now. And guys, I mean, let me show you something. Particular, oh no, thank you. I mean, it's over now. But guys, it really takes a hell lot of a time of mine. I mean, it takes at least of 2 to 2.5 hours for me to make the one particular video. I mean, at least of 7 to 10 hours to rip and encode and re-encode of any video, and that's the minimum time that is taken for that it takes for one video to uh, record, to encode, to re-encode, to upload, and to make it available for you guys. And but till now, the two videos that I have made, and this including this one particular video, uh, it- all the videos have taken me like have taken me anything like not less than 17 to 18 hours. And that's, guys, like seriously a hell lot of a time, a hell lot of efforts, and a hell lot of an exertion and frustration and each and everything, a hell lot of hard work. If I try to sum it up in one or two single word, because hell, hard work is actually two words, so I can say it if I try to sum it to one single word. So whatever. So guys, I mean, a bit of more enthusiasm. I mean, I know these topics are of bit you are not pretty much interested into Linux as I am, or as some other guys are, or other, I mean, as I am, is basically. So I mean, okay, it's all right, but guys, a bit of more response, a bit of more enthusiasm will sincerely will be appreciated, will be like hell of appreciated. I mean, I'm doing it all for you guys so that you learn with it, so that you can enrich yourself with the help of it. I'm available for your help, your service, like 24 into 7. Whenever I'm awake, you can reach out for me anytime, anywhere, for any kind of help or troubleshooting or anything that you may need or you may want. So, guys, I mean, try a bit more to give in response, be it in the feedback or be it in the response, because it really took me a hell lot of a long time to reach at some of at the place I'm where am I to the level of knowledge where am I when it comes to Linux and open source and each and everything. And with time, it also actually costed me a hell lot of frustration, a hell lot of money, a hell lot of everything. I don't want anyone of you to go through the same, and that's why I'm putting all this effort into this. So guys, please, I mean, make it worth, so that at the end of the day, I also feel that the all efforts that I'm actually making, I'm actually trying to make, is worth something. It's not totally worthless, but it's actually for someone, is actually is benefiting someone. So that's all. It's pretty plenty of a talk for now. Hope it helps. And let me clear it. So the topics left are ACL, sorry, access control, ACL, this. I'll be adding more topics to this. Until then, I'm signing off. This is me, Arash, saying goodbye. Catch you in the next video. Bye. Stay